our third installment of rationalizing denominators. For example 11, we see 4 rad 7 over radical 3. This is an unstable relationship, so we would have to multiply the top and the bottom by rad 3 to stabilize our denominator. As we do so, the 4 stays right where it's at. With radical 7 times radical 3, we don't have the opportunity to bring any numbers out, so we'll go ahead and multiply those, and this would become a rad 21 over, and then rad 3 times rad 3 is rad 3 squared. 3 squared comes out as a regular 3, and we end up with 4 rad 21 over 3. I cannot stress enough, be careful. Some of you are going to want to over cancel. You're going to cancel when you're not allowed to. My pen is going back and forth here over the 3 and the rad 21. Yes, they have a common factor, but you cannot cancel a number that's under the radical with a number that is free. And so when you look at this, do not cancel that. This is your final answer. Let's move on to an example 12. With example 12, I'll do 2 over rad 300. With the rad 300, I mentioned earlier, be careful not to just blindly multiply by whatever's on the bottom. Look at the numbers, think about the numbers. I recognize that 300 is 3 times 10 squared under that radical, which means that I can bring a 10 out before I even begin the problem. And you want to do that to avoid getting really large numbers or having to cancel multiple times. And so I'm going to write this as 2 over, this 10 will come out from underneath the radical, and I leave that 3 under the radical. And so then I have this 2 over 10 rad 3. I'm looking at an opportunity where I can cancel here before I even begin the regular process. The 2 can become a 1, the 10 can become a 5. And so now I have a fraction that says 1 over 5 rad 3. Now we begin this concept of getting rid of the radical in the denominator. We can simply multiply top and bottom by radical 3 to rationalize, stabilize that fraction. And this would become 1 times rad 3 is just radical 3 over 5. Now rad 3 times rad 3 is a regular 3, so it'd be 5 times 3, which is 15. Final answer, rad 3 over 15. And once again, do not get suckered in where you try to cancel when you're not allowed to. Free versus jail. They can't interact, so we call it rad 3 over 15. That is an appropriate answer. Let's move on. We'll do an example 13. With example 13, we've got 18 over rad 27. With 18 over rad 27, I recognize that 27, just like the rad 300, has an opportunity to be broken down, and I'm going to take that opportunity. So I'm going to say that this is 18 over, now 27 is 3 squared 3 under the radical, so I could bring a 3 out and leave a 3 in. Remember, when the number comes out from underneath the radical, it loses its exponent. So then when I'm looking at this, the 18 and the 3 can be reduced. I can call that 6 over 1 rad 3. With this scenario, I'm not allowed to have the radical on the bottom, so I'll multiply top and bottom by rad 3. As you multiply the bottom by rad 3 times rad 3 would just be a regular 3. Upstairs we'll have 6 rad 3, and we have to inspect that to see if we have the opportunity to cancel or reduce. With both of these being free values, I do have that opportunity. 3 goes into both of those. 3 goes into 6 twice, 3 goes into 6 once, or 3 once, and we can call this 2 radical 3 If you prefer, you can go over 1, but it's not needed. In fact, I prefer to write them like this. They look cleaner. So my final answer here is 2 radical 3. Let's do another example. Example 14. I've got 1 over 5 rad 7. Fairly simple example. My issue, I don't have any place where I can cancel. My issue is having this radical in the bottom, so I'll simply multiply top and bottom by rad 7. That's the only thing that's causing the issue, is that radical. And so when I multiply that by rad 7, 1 times rad 7 upstairs is radical 7. Downstairs it'd be 5 times radical 7 times radical 7 is a regular 7. So 5 times 7 is 35. So it becomes radical 7 over 35. And we're going to finish with example number 15. I've got a 10 rad 8 over 3 rad 5. I do not have any opportunities to cancel, and so I can look at multiplying top and bottom by rad 5. As I multiply by rad 5, we'll see where this takes me. In the bottom, rad 5 times rad 5 is a regular 5. 3 times 5 becomes 15. Upstairs I have this 10. And before I blindly multiply the rad 8 times the rad 5, if you were following in our previous lessons, I never just blindly multiply. I'm always looking for pairs. 8 is actually 2 squared 2. And then I've got this 5. All that's under a radical. I could bring this 2 out. So I'll bring the 2 out. And this 2 and 5 would stay in, so I can call that radical. 2 times 5 is 10. As I'm looking at what I have here, before I multiply this, I do recognize that I could reduce this right here. And you're allowed to cancel. Canceling should always be done through multiplication. When you have multiplication present all the way through, oh yes, you should cancel. So this 10, I could divide it by 5. 10 divided by 5 is 2. This 15 I could divide by 5, which gives me 3. And so as I'm looking at this, I can get to my final answer. It leads to a final answer where I multiply all the free values. 2 times 2 would be 4, radical 10 over 3, which satisfies the condition of rationalizing the denominator, making that denominator so there's no radical there. Now, if you preferred, you could have multiplied this right here, called it 20 over 15, and reduced that to 4/3. So it really just matters how your mind works. Alright, so you've got 15 examples. Hopefully you'll be successful, can't talk this morning. Hopefully you'll be successful in completing your homework, and all goes well.